Hello! Today, we're going to tackle a complex-looking algebraic expression and simplify it step by step. By the end of this video, you will be able to identify and factor out common terms, distribute and combine like terms, and simplify expressions by factoring out a negative sign. Our main goal is to simplify the expression. The quantity x squared minus 2 cubed times the quantity x plus 4 squared minus 2 times the quantity x plus 4 times the quantity x squared minus 2 to the fourth power. This expression might seem intimidating at first, but we'll break it down into manageable pieces. The key is to look for common factors, just like you would with numbers. Our first step is to identify the common factors in the expression. Think of this as finding the greatest common divisor, or GCD, for algebraic terms. Let's look at our expression again. We have two main terms separated by a minus sign. The first term is x squared minus 2 cubed times x plus 4 squared. The second term is 2 times x plus 4 times x squared minus 2 to the fourth power. Now let's compare them. Do you see any factors that appear in both terms? Notice that both terms contain the factor x squared minus 2 and the factor x plus 4. Great, now we need to find the highest power of each common factor that is present in both terms. This is the greatest part of the greatest common factor. For the factor x squared minus 2, we have a power of 3 in the first term and a power of 4 in the second term. The smaller of these two powers is 3, so our common factor is x squared minus 2 cubed. For the factor x plus 4, we have a power of 2 in the first term and a power of 1 in the second term. Remember, if there's no exponent written, it's understood to be 1. The smaller power is 1, so our common factor is x plus 4 to the power of 1, or just x plus 4. Therefore, our greatest common factor, or GCF, is x squared minus 2 cubed times x plus 4. This is the expression we will factor out. Now that we've found our greatest common factor, the next step is to factor it out from the original expression. This is like reverse distribution. We'll write our GCF, x squared minus 2 cubed times x plus 4, outside a large set of brackets. Inside the brackets, we'll place what's left over from each term after we divide by the GCF. Let's do this one term at a time. First, let's look at the first term, x squared minus 2 cubed times x plus 4 squared. We divide this by our GCF. The x squared minus 2 cubed terms cancel out completely. For the x plus 4 terms, we use the exponent rule that says a to the m divided by a to the n is a to the m minus n. So x plus 4 squared divided by x plus 4 to the first power is x plus 4 to the power of 2 minus 1, which is just x plus 4. So x plus 4 is the first part of what goes inside our brackets. Now for the second term. Remember the minus sign in the middle? The second term is 2 times x plus 4 times x squared minus 2 to the fourth power. We divide this by our GCF. The 2 remains. The x plus 4 terms cancel out. For the x squared minus 2 terms, we have a power of 4 divided by a power of 3, which leaves us with a power of 1. So we're left with 2 times x squared minus 2. This is the second part of what goes inside our brackets. Putting it all together, our expression is now factored into x squared minus 2 cubed times x plus 4, all multiplied by the quantity x plus 4 minus 2 times x squared minus 2. We've successfully factored out the GCF. Now our task is to simplify the expression inside the brackets. This involves distributing and combining like terms. Let's focus on the part inside the brackets, x plus 4 minus 2 times x squared minus 2. The first step here is to distribute the negative 2 to the terms inside the second set of parentheses. We multiply negative 2 by x squared, which gives us negative 2x squared. Then, we multiply negative 2 by negative 2, which gives us positive 4. Now that we've distributed, we can combine the like terms. Like terms are terms that have the same variable raised to the same power. In our expression, we have a constant term of 4 and another constant term of 4. We also have an x term and an x squared term. Combining the constants, 4 plus 4 equals 8. The x and x squared terms don't have any other like terms to combine with, so they stay as they are. So the simplified expression inside the brackets is negative 2x squared plus x plus 8. It's standard practice to write the terms in order of decreasing power, from the highest power to the lowest. We're almost there. We've factored out the GCF and simplified the expression inside the brackets. Now, let's put it all back together. Our expression is now the GCF we found earlier, x squared minus 2 cubed times x plus 4, multiplied by the simplified expression from the brackets, negative 2x squared plus x plus 8. This is a perfectly valid answer. However, in mathematics, we often prefer to have the leading coefficient of a polynomial be positive. The leading coefficient here is negative 2. To make it positive, we can factor out a negative 1 from the polynomial inside the brackets. This is a common simplification technique. When we factor out negative 1, we change the sign of every term inside the parentheses. So, negative 2x squared becomes positive 2x squared, positive x becomes negative x, and positive 8 becomes negative 8. Now, we can substitute this back into our expression. Our expression becomes x squared minus 2 cubed times x plus 4 times negative 1 times 2x squared minus x minus 8. Finally, we can move the negative 1 to the front of the entire expression to make it look cleaner. And there you have it. The fully simplified expression is negative x squared minus 2 cubed times x plus 4 times 2x squared minus x minus 8. Let's quickly recap the steps we took to simplify this expression. This process is a powerful tool for simplifying many different types of algebraic problems. First, we identified the greatest common factor, or GCF, by finding the common terms with the lowest powers. Second, we factored out that GCF from the entire expression. Third, we simplified the expression that was left inside the brackets by distributing and combining like terms. And fourth, we factored out a negative sign to ensure the leading coefficient of the polynomial was positive, which is a standard convention. By following these steps, we transformed a complex expression into a much simpler factored form. You are now able to identify and factor out common terms, distribute and combine like terms, and simplify expressions by factoring out a negative sign. Great job!